Okay, today what we're doing is we're starting our units on factoring. So we're going to be taking and factoring out the greatest common factor, okay? What that is that is the number that divides evenly into two numbers, number or variable is what we're looking at. It's kind of like when we reduced fractions. We would take the greatest common factor and reduce our fractions down by that number. We're doing the same thing, except right now we're going to be looking at monomials, binomials, and trinomials and pulling out that greatest common factor. It's really, once you see it, you get really pretty good at it, but you got to see it first in order to be able to do it. So here's what we're looking at. Okay, we got two monomials here, or two terms. All right, and what we want to know is, what is the greatest common factor that can come out of both of these? Right? That's what we're looking at. And when you look at this, if you'll look at it, notice this is 27 and this is 300. Deal with that number, the coefficient first. Deal with the coefficient first. And try and take that number out. Well, 27 is divisible by 3, and 300 is divisible by 3. So we know we can take a 3 out of both of those. Right? And then we need to check the other numbers and see if that's true. Well, what happens is when I take 3 out of 27, I get 9x. And that's what it is. 3 times 9x gets me 27x. Okay? When I take 3 out of 300x squared, I get 100x squared. Okay. Well, there's not a number that can go into 109. So 3 is part of what I'm going to take out. It's part of my greatest common factor. But then when you look at it again, we also have the variable that we got to look at. We have this variable here, x and x to the second power. I can take the x out of both of these. So when I do that, I get 3x times 9, and I get 3x times 100x. So our greatest common factor that can come out of both of these is that 3x. That's what you're looking for. What is that number that I can pull out of both of those? Okay, that's what we're trying to do here. Okay, so we have 3x here, which is what it should be. Yeah, 3x. Okay, and write the GCF of these two numbers. So right here, I would put 3x because that's the number that I can take out of both of those. That's what we're looking for. Okay? And we're going to do a couple of these so that you can see kind of how that process works and what's going on. So, here we go. All right. So here's a good one. Okay? And notice there's more variables in this. Well, first thing, 640 and 6,400, you can take 640 out of those two things. Okay? So you'd have 640, x to the third, y to the fifth. Okay? I can take those out. These two things, they're the same thing. That's important to see, is that they're the same thing. And then, sorry. And then over here, I can take 640 out of this one, and you have 10x to the third. Okay? This and this are the same thing. Right now, this can be taken out of both of them. But then if you look, you got to go into the variables too. Well, you have x to the third here and x to the third here. I can pull that x to the third out also with it. So we end up with 640 x to the third times y to the fifth. That's that top one right there. And then down here, you end up with 640 x to the third times 10. So our greatest common factor that we can take out of both of those, right, is this 640 x to the third. And that's what we're just starting to get into this, and this is going to come into play a lot later on, but you've got to know how to do this. When you see these, you need to be able to do that. 640 x to the third. All right? here's a pretty good one too. 1,200 x to the fifth, y to the first, and 14 x to the third, y to the first. All right, so first things first, deal with your coefficients. What can come out of both of those? Well, I know I can take a 2 out of both of those. So if I take 2 out of that, okay, that gets me 600 x to the fifth, y to the first, and that gets me to 7 x to the third, y to the first. All right, I don't think 7 goes into 600. No, it does not. Okay, so we're done with our coefficients. The 2 is going to be the number that comes out of there. Now we go to look in our variables. And guys, if you get this as a prime, check to see if you can just divide it and see, okay? But now go to your variables. Well, we have x to the third and x to the fifth. Well, I can take x to the third out of both of these, all right? So on this top one, 2 x to the third, parenthesis, 600 x to the second, y to the first. Now look, if I multiplied that back through there, I would end up back here. I mean, you have to end up back where you started when you're taking that out. They've got to be the same thing, okay? So here, 2 x to the third, 7 y to the first. Now take a look. Is there anything else that we can pull out of that that would be a part of that? Well, if you're paying attention, y to the first and y to the first is in both of those. So we could take that out also. So our greatest common factor when we pull out all of it is 2x to the third, y to the first. Because I'm going to take this out and this out. And that's where we're going with that. So if all we're looking for is this is the greatest common factor out of both of this and this. That's what you're looking for. Okay. All right. That's pretty much what it is for that. See, 2x to the third, y to the first. Okay? All right. So there's that. And that's just taking the greatest common factor out. Again, if you can reduce a fraction, you should be able to do this. All right? Now, the next thing is we have a trinomial here. And we want to pull out the greatest common factor out of that. Okay? So when we do this, we're going to look at it and say, what goes into each one of those terms? And we're going to take that out. Well, if you look, you got 12, 20, and 20. We can pull out, well, a 4. 4 times 3 gets us 12. 4 times 5 gets us 20. And we can pull that out. Okay? So we can pull 4 out. Pull 4, and that gets you 3q plus 5q to the third plus 5q to the second. Okay, and that's what that would look like so far. But now we also have q in here, in each one of these terms. So since the q is in each one of these terms, we can pull a q out also. All right, so 4q, because that's 4 times q, times 3 plus 5 q to the second, because I just took one q out, plus 5q. And this is what this would look like. Now, depending on how they ask this, will depend on if you give them all of this, or if you're just going to give them the greatest common factor. Now here they ask for just the greatest common factor. So this is the part that you're going to want, right? 4q. Depending on what they ask, right? If they say just separate it, you may just put this whole thing in there. But if they want to write the greatest common factor, well, that's this number that comes out of all of these terms, right? But if I was to take this and multiply it back through, I would end up right back here. And we need to be able to multiply this through to get here, or we need to be able to pull the 4 cube out to get here. So you gotta be able to go back and forth between the two. And it's gonna pop up at different times depending on what we're looking at, where this is really the only way that we can continue to move forward in our problem. All right, so be aware of that. Okay. And once you see it, you start to get a lot better at it. You start looking for certain things. All right, 36b plus 36v to the third plus 9v to the second. All right, so first thing, you might go, oh, 3. Yeah, 3 would work, but is it the greatest common factor? Well, if I do 9, I can do 9 times 4, that gets me 36. So I can pull a 9 out of each one of these. All right, so 9, and that's all I'm looking for. What can I divide all this stuff by to get out of there, right? So I pulled 9 out. That gets me 4v plus 4v to the third plus v to the second. Close it in. All right, so if I multiply 9, because I got to check to make sure that if I do this, I get back to here. Okay, 9 times 4 gets me 36. Okay, v. 9 times 4v to the third gets me 36v to the third. Okay, so far so good. 9 times v to the second gets me 9v to the second. Okay, so I'm good. Now, is there anything else that I can pull out of there? And you're going to get to the point where you're like pulling 2 things out at a time. Okay, so v goes through all those. So 9v parentheses 4 plus 4v to the second plus v to the first. Close it in. All right. So right here is my greatest common factor, and that's what you're looking at. That's what we're looking for. Again, write the greatest common factor. Pull that out. Now we can do this check to make sure that when you multiply it through, it gets you back to here, because if it doesn't, you did something incorrect. Okay? This is why we spent so long on our exponent rules. Make sure that you know those so that you know how this actually works with this. Okay? Guys, once you can do this, you're going to be in a good spot. So that 9v was our greatest common factor. And this is all we're looking at right now, is what is our greatest common factor? Look at this, 2v to the 5th plus 7v to the 4th. Well, there's no coefficient here that I can actually use to pull out, but I can pull out the v, okay? v, parentheses, 2 plus 7. And I left the v's off real quick just to see this. How many of those v's can I pull out of this? I know I can do at least one, okay? But look, we have 5 here, we have 4 here. Well, I have 4 in each one of these. So I can actually pull out v to the 4th out of there. So I have v to the 4th, that leaves me with 2v plus 7. This is my greatest common factor, is v to the 4th. Okay? So I pulled out as much as I can, and that leaves me here. Right? Glad I did one more, because that's good. v to the 4th. And that's what you're looking for. What is the greatest number I can pull out? Okay? If you can do this, you're going to be in a good spot. If you have any questions, let me know.